Thank you, Chet. So fire hose number one. Our project is Lincoln Elementary, which is under Oakland Unified School District. They serve about 50,000 kids, and about 750 of those go to this school for in K through 5. And we thought, since it is an elementary school, that we create a case study that was tuned to our harshest critics, the 6 and 11-year-olds that go to this school. And it is a mid-century modern building and campus, originally built in 1961. It's in Oakland, California, and it is an example of a very typical urban site. It is 3 miles from the lake, 4 miles from the bay, and a quarter mile from 101, which is a heavily used artery. And a little bit more information about its connection to Chinatown and Lake Merritt and Interstate 880. Sorry, it's a quarter mile from 880, not 101. There you go. Okay, so it's a 1.4 acre site. It's really just a block big, and is largely a hardscape environment. Of the space that's there, I think the CDE says on Title V that you need about 59 square feet per student, and this school only has about 9. So you can tell it was built at a time when it didn't have that connection to play space. But it is in a vibrant community. It is near Chinatown, the city center, Old Oakland, Jack London Square, that's its backyard. And a little bit more about this site. It is in Climate Zone 3. And it is a blue ribbon school, and so it has some really great assets, and it is really a great place of community, and it's a place of pride. They say, the principal told us that the teachers think of it as having a Lincoln way that's really connected to how they treat each other and how they connect to their students and the broader community. But it is a place of asphalt. You can tell those little green zones are really the only green they have is a vertical, thin connection to nature. And 95% of the school site is impervious, and 100% of its play yard is impervious. So it is a bit of a harsh environment, a place of noise, construction, buses, a lot of traffic. And in their school building, it is a place that's often too hot and too cold. And it is much like a lot of the urban schools that we know of. 25% of the traditional public schools are in urban environments. And it was like many of those buildings. It's got a flat roof, a modular exterior, and not a lot of space around the site to create a place for play or expansion. So like a teenager, it's got good bones and bad skin. It's really leaky, uninsulated, because it was built at a time when energy efficiency really wasn't considered. That wasn't one of its top priorities. So DSA asks, how can we reduce energy and water and consumption in an existing building? And we thought, gosh, we've got all that flat roof, and we can count the toilets. And because of the fact that it's 2-story and good amount of roof, we could cover PVs over the whole site, change out all the fixtures, and get really pretty close on the net zero water, and definitely get to net zero energy and help save the campus, the school, some of that $39,000 they spend per year on energy. But really, is that all there is? Is that the main opportunity? And if you only have a chance every 10, 15, or 20 years to make a difference, don't we want to think deeper? Can we look at the Green Ribbon program that's modeled after the Blue Ribbon program and think about how can we reduce environmental impact and cost, improve health and wellness, and affect environmental and sustainability education to really affect our sustainable natives? Can we banish broken or static or inflexible classrooms? Can we take STEM out of the box and really connect our students to nature, to think differently about educating them through systems? Can we boost our students' superpowers and provide a place of health and wellness? And can we make a place that's comfortable for everyone, everywhere, at every time? So we think what you really need to do this is a super committed team. And we learned, or I learned, that the Justice League of America is a great team, but they don't necessarily like each other. But they have a common goal. So that common goal is what drives them towards good change. And so our Justice League, or our super team, and we do like each other most of the time, would normally include the school, DSA, at the table to think about what the opportunities are for each project. And so this is our super team, which includes the principal. And we think about how everything is connected. It's not just a connected team, but it's a process of looking for things that can relate and connect and do good service for many, many concerns, energy efficiency, saving money, and a healthier place to be. And can you take some of those elements? Can changing out a facade actually improve the connection to the community, also provide a more comfortable environment, and allow you to save money? Can you take a place, a garden that's sort of neglected, add in a rainwater tank that helps to feed that garden, make it an educational opportunity that the students can really be a part of? So we start by investigating, looking at what we have at our site. These are just a couple of examples of looking at what our water systems were like, what our ambient noise levels were. It happens to be that the school was off the charts. Sometimes the readings were at 70 decibels. We walk and we measure. We really just pound the pavement, try to understand what there is, take, again, more measurements, engage the users, talk to anyone who would listen to us and tell us their stories, examine the records. Oakland Unified had some great past master plans and data that we could draw from. We got some more information from the CEC through Chet's group, and then we start to budget. We start to budget what we believe we have through examining the bills, and then targeting what we think is possible. So our EUI, and that is our energy use intensity, which is a measure of all energy used, so electricity and gas, divided over square footage, is about 30, and that's really not so bad. Some of the concern was maybe that they just weren't using any energy to heat the place, so that might have been the low number. And also the current water usage is 3.3 gallons per student. So our targets were based on trying to shave off 30 to 50% of each of what the elements that we were looking at. Could we also increase stormwater infiltration by 30% to reduce the amount of pollutants that were hitting our waterways? And so, again, take all that evidence we gathered, and we did this with very simple devices. We kind of thought of ourselves as the scrappy team. A FLIR attachment to an iPhone helped us get some thermal imaging. On the lower left-hand side, you can see those that red shading is how much heat is actually penetrating through the building. So they're losing their energy through the skin. And the upper level, again, an app that was taken on the phone to tell us about the acoustical readings. And then we challenge each other with the assumptions, kind of push and pull back and forth to figure out what is the best strategy, what were the best interventions, if you will, to bring us to those targets. And keeping that eye on the ball, which is really connecting some of these dots to make for more comfortable conditions and lower bills and a better place for sustainable natives. So our super team starts to identify the villains, which in our case was definitely heat gain, water pollution, glare, no connection to nature, wasting money, too noisy, and no time to connect again to our students. And then we grab that toolkit, which can, you can all read this, right? Which really gets filtered through an analysis. Can you do certain aspects that then not only provide lower bills, but more comfortable conditions and an opportunity for teaching? And that this was analyzed by the whole team. Can you find those connections to nature? Can you find the connections to better places of learning and enhanced curriculum. How can you find that web of benefits? And then we start to look at taking those tools and applying it to place. So this is sort of a section cut through our site. If there's no time to connect to sustainable natives and a lot of heat gain on the site, how can we improve that space that's too hot and too cold, and actually a place where some of the community sits and smokes right next to the windows? How can we improve all of those conditions? So you round up those tools again. These are our superheroes, and you start to employ those over the site. And so you take that same section and think about how can you collect water for use in the landscape? How can you create a buffer that uses that water to provide a little privacy edge to the students within the classrooms, both on the interior play court and the outside? Can you redo the envelope because it's a modular section, to provide better glazing to prevent solar heat gain, include fans to provide a more comfortable condition, solar tubes or solar skylights from above, maybe redoing the radiant flooring with a very thin product, it's called Veritherm, that helps, it's less than an inch, that helps provide, again, a more comfortable condition, adding insulation to the outside, again, to provide a better barrier, and thinking about that landscape that helps provide some shading for the exterior, but also prevent folks who might want to smoke at that edge. And then think again about how to improve a place for growing and learning and connecting, that permeable paving, using that so they could filter out particulates that end up getting into the lake and into the water. It reduces the demand on the urban infrastructure, but also is a way of calculating and maybe measuring the positive aspects of what you're gathering. So what you take, you also measure, and you try to find that cycle for educational purposes. And then, of course, adding solar to the roof as we start to measure our reduced energy bills. So you take what we have, this very sort of non-permeable place, and you start to make that fifth facade all performative. Every aspect starts to do something to the good, whether it's to take in water, to take in energy, and to provide for education. And so these are our report. This is our report card, if you will. Collecting all that rainwater helps to connect the dots, again, to students. Increasing the on-site permeability infiltrates about 90% of the annual runoff, about 538 gallons, removes maybe 130 pounds of pollutants. On the building water side, by changing out fixtures from 1.6 to 1.2 gallons on the toilets, and 1 gallon to a pint or 0.125 gallons, and then changing out aerators really helps reduce the water demand by about 40%. Capturing the rainwater for irrigation, again, can reduce the demand, the potable demand, by about 80%. And that changes the reduction from 3.3 gallons per student to 1.8 gallons. On the energy, replacing the fluorescents with LEDs, also changing the light levels for appropriate light levels helps reduce the energy about 50% and provides a more comfortable condition. Replacing the single pane glazing to high performance reduces the air leakage and increases the use of daylight, daylighting as a source, and adding PVs to the roof helps to reduce the bills. What the point of all this, too, is that there's a sequential intervention that can reduce the EUI from 30 to 23 if you take them in steps. So maybe you can't do them all at once, but it speaks to this master plan idea that Chet was talking about. And if you do that, if you take those, if you reduce before you produce, you can save the amount of PVs you would add to the roof to 14,000 square feet of PVs versus 25,000 square feet. And that's a savings of investment about 365,000, assumed at 3 to 350 a watt. So on the habitat side, we're reducing the amount of increasing the amount of useful landscape about 20%. It increases the stormwater filtration and 100% connection to nature. Adding plants in rosemary and lavender helps connect students to pollinator pathways, regional climate, and productive edibles. And really on the comfort side, adding the ceiling fans can provide, with that occupant control, somewhere around 4 to 7.5 degrees of comfort in a more passive way. Switching again to the glazing increases the comfort to 70–80%, and adding insulation does quite the same. And the acoustics, we believe, can be improved by about 15% because of that dual pane glazing and insulation at the exterior. So really, the happy report card would be the happy student, because if we can create a place that's just right all the time, then we have won. Thank you.